It is now my pleasure to turn today's program over to James Goettler, Director of Metalworking Innovation. Mr. Goettler, the floor is yours.
All right. Frederick, you can hear me okay?
Oh, yes, we can hear you loud and clear.
Perfect. Thank you. Good morning, everybody. Frederick, thank you for everything and teeing this up for us today. Good morning. Excited to spend some time with this group today to talk about MSC MillMax, latest innovation that MSC has introduced into the metalworking and manufacturing marketplace. As Frederick had shared, my name is Jamie Goettler. My responsibility at MSC is metalworking sales and in particular innovation, particularly as it relates to metalworking and manufacturing innovation. I've been with MSC for 20 years. I live in Pittsburgh, Pennsylvania, and spend really the better part of my time these days, along with a great group of MSC associates and colleagues, identifying those particular things that MSC can bring to the market that provide relevant improvements to our customers' business. And today, like we said, we're going to start with MSC MillMax as one of them. We have many other innovations that we're working on these days, but MSC MillMax is really making quite a dent in a good way with our customers, and we're excited to spend some time talking about it today. Joining me today is Scott Stickney. He is MSC's National Metalworking Sales Manager. He manages our metalworking specialist team. He's going to be receiving the questions that you ask throughout this, and he'll interrupt me as needed to interject questions. And so with that, I welcome that ability to answer questions as you have them early on and throughout the presentation. And then we'll have some at the end that you may have questions on as well, particularly as Frederick noted. I'll be sharing a video probably in about 15 minutes or so. And a lot of questions normally come up when we do these national webinars. So please feel free to ask the questions, chat the questions, and we'll get the answers to you during this session. So why don't we go ahead and we'll get started. So the objective of today's meeting, of course, is to introduce MSC MillMax to our customer base that's on this call. It is an exclusive technology, and it's a service. Important to note it as such because we're not trying to sell hardware and software. We've actually made the investment ourselves in the guise of improving our customers' business, in particular, obviously, in this case, with milling operations. And we're going to talk in a moment about why milling operations are so important. But this exclusive technology and service really puts us in a great position to stand behind our brand promise of built to make you better, specifically as it relates to your milling operations that you administer at your respective companies. Interestingly, and you'll see as we go throughout the presentation, of course, with the video and subsequent things I'll share, that MillMax uses science, what's known as machining dynamics, rather than human guesswork, to optimize our customers' speed with which they are able to machine parts. That improves their productivity. And as we're improving productivity in these regards, it also stands to improve our customers' profitability. And as I transition to the next slide, you'll note that the most common customer concerns that we recognize in America for businesses like yours, durable goods manufacturers, those companies that are making automobile parts or airplane parts or medical parts or anything metal at all. Traditionally, the primary concerns of American manufacturers, especially over the course of the past 3 or 4 years, are the ability to be more competitive. Can you be competitive in the domestic marketplace? And now there's really a great opportunity in the global marketplace, due to the pandemic and the want to reshore manufacturing back to America. The ability to be competitive and to maximize your profit is concern number one for businesses like yours. The second one, traditionally, is the ability to grow your business year over year. Just like MSC wants to, just like our sales team wants to, your companies want to not be flat every year, not go down, but to grow every year. And in manufacturing, if you really boil it down, there's two ways to grow your business. You can either go buy more equipment spend the capital to buy more machines that can create more throughput, or you can find capacity on your existing equipment. Maybe you can make more on the existing equipment if responsibly you're able to improve the speeds with which and the productivity with which you operate. And we're going to attack that as well. But to do both of those things in the face of the manufacturing skills gap. So companies like yours want to be more profitable. They want to be more competitive. They want to grow business year over year. But man, this skills gap is really pervasive and makes things a little bit difficult. So MillMax attacks those things. You might have seen or heard, whether it's through our sales team or whether it's through press releases, that we have a partnership with Oak Ridge National Laboratory, and we're super fortunate to have that partnership, and what a great group of colleagues that we are able to work with. And MillMax really got its start as MSC was considering this, what we called at the time, milling optimization product. And we were testing it in the field and making sure it worked as well as we were understanding that it would. And while that was happening, you notice this assessment on the left-hand side of the screen. Essentially, what had happened was there was an assessment done of the American manufacturing base by the federal government, and it found that, if there was a need for a wartime effort, that American manufacturing at large was not prepared to support that kind of effort. Not nimble enough, the skills gap was pervasive, intellectual property was overseas of things that we may have made, and these things needed to be buttoned up, needed to be improved. Well, at the time we were considering MillMax, we were introduced to folks at Oak Ridge who house what's American Manufacturing Leadership. There's a facility called the Manufacturing Demonstration Facility, and their goal was to improve American manufacturing to make us more safe and more secure by an improvement in our manufacturing and machining practices. Well, at the same time, we do that. You can see in the middle of the screen a quote from one of our colleagues, Scott Smith, who leads intelligent machine tools for Oak Ridge, stated, improving CNC machine tool performance ultimately will lead to energy and cost savings, extended tool life, improved productivity, and greater competitiveness for U.S. manufacturers. So with this particular innovation, MSC is really in a great position to help, improve homeland security by virtue of improving American manufacturing productivity, but also to make you more competitive and to help you grow your business. If that story is of interest to you, I'll recommend taking a look at the Modern Machine Shop issue from back in October of 2020. We were fortunate to have the cover story, and Brent Donaldson, who's one of the top writers in the industry, detailed this, and it's a really interesting story. I invite you to take a look at it at some point. So let's talk about milling before we start to show you how this MillMax thing works. First things first, milling is a great place to start. If we're going to work to improve your profitability and your productivity and to help improve the American manufacturing base, 3 times more dollars are spent annually on milling centers or machining centers than are turning centers, which are the 2 most common pieces of metalworking equipment, of course, as you know. The other thing to consider is 40% of all cutting tools used are milling products, and then the other, 60% or so would be made up of turning inserts and hole making or drilling, threading or tapping, saws and other types of cutting tools. So milling is the dominant application that's operated in America. And then Modern Machine Shop also had shared with their top shops that 93% of shops in America have milling machines as opposed to 74% have lathes. Now, that's not to discount the importance of turning or lathes, because we have an innovation that we're excited to introduce coming up really soon that has to do with that. But boy, milling is a really great place to start. So, really without any further ado, what I'm going to do is I'm going to stop sharing my screen for a second and migrate to this video that, as Frederick had outlined, he'll give you some guidance to remind you here in a second while I'm doing that. And I'm going to walk you through, the physics of how MillMax works, what you can expect as a metalworking specialist works at your facility to administer this type of technology, and then what are deliverables to you. And when I'm finished with the video, I'm going to showcase these dashboards, this dashboard that gives your engineering team, your programming team, your machinists the ability to be strategic in how they operate. Okay, Frederick, thank you. I'm going to go ahead and get started. And like I said, keep the questions or start the questions coming along, especially with the video. The things that I share normally compel customers and decision makers about certain aspects of the technology. So you start chatting those questions. But without any further ado, let's get started.
We don't make milling machines, milling tools, or milling software. We just make them all mill better. Here's how. Unlike other machining operations, where the cutting edge never leaves the workpiece, milling has hundreds of individual tooth impacts per second, generating forces that cause deflection and vibrations. Like this 75-pound anvil, every tool is flexible and vibrates at its own unique frequency.
Pause the video, and you should see on the screen right now what we refer to as an instrumented hammer, as well as a milling setup in a horizontal orientation. And with that particular hammer, it's actually connected via cable to a metalworking specialist laptop. So this is on your milling equipment at your facility using, of course, an end mill. It could be solid or indexable in the holder, and then, of course, within the spindle of the machine. We refer to that as an assembly. That we are going to understand the frequency response function of that assembly and how they want to operate together. And the means by which MillMax works is our metalworking specialist, let's say in this case it happened to be me, would tap this tool a few times in what's known as the x-axis or x direction, and then turn that tool and then tap it in the y direction. There's an accelerometer you see attached to the opposite side of where we tap this tool. And that accelerometer is identifying how that system or that assembly vibrates when it's struck by that hammer. So the hammer says, Jamie Goettler hits the tool this hard, and when he hits it this hard and many pounds per square inch, this is how much that system vibrates. That information goes to the laptop in an elaborate program that's built, and it knows. We have incorporated what's the diameter of the tool, how many flutes in the tool, how far is it sticking out of the spindle, what type of holder is it in, what type of machine is it in, how much horsepower does that machine have, what's the torque rating of that machine, the RPM max, if you will. We have all of that information, and much of it in a database too, by the way. And literally within seconds of administering, and then select, of course, the material you're about to machine. Is it steel? Is it cast iron? Is it stainless steel? Is it aluminum? Is it titanium? Any material. And it will tell us in a dashboard form the ideal way to operate this tool in that machine. So this is how that test is administered by our metalworking specialist. Now, what I'll also add to you before I go back and continue the video, MSC has been testing end mills just like you have and just like our supplier partners have for years and years and years. The average end mill test we found, but we validated with Cutting Tool Engineering had posted an article on this a few years ago, that the average time of testing an end mill is 3 to 8 hours to find stable cutting parameters. What MillMax does is in less than 15 minutes, it showcases optimization. And so you'll see after I'm done with this, I'll highlight some of the metrics and what we're seeing as we administer this technology on shop floors just like yours. And it's pretty amazing stuff. So in a very short amount of time, we're able to help you optimize. So I'm going to continue.
Why is this important? The tool point deflects and rebounds at a frequency determined by the flexibility of the tool holder and spindle. You also have the tool impact frequency determined by the number of teeth and spindle speed. You have to get the timing of these two frequencies just right. If you do, each tooth is cutting equally, so tool life, productivity, and quality are maximized. If the timing is off, a tooth arrives too early, undercutting and throwing off the next tooth. It arrives too late, exceeding the programmed chip thickness, leading to premature tool failure, poor surface finishes, and possibly scrap. This timing mismatch keeps getting worse and leads to chatter.
stop here, a couple of things that I would want to share. So first of all, what you just heard there and saw there is chatter. Chatter is just devastating on a number of different levels. And first of all, it's bad for the workpiece. You get substandard finishes, potentially if you crash or break an end mill, which is not good in and of itself, you might scrap a part. It's not good for the spindle of the machine. So in a number of different ways, chatter, again, which is the killer of all milling cutters or end mills out there, is a bad thing. You know, what we're going to find is how that system, how that assembly wants to operate in the most stable and optimal manner possible. What's also noted on the screen is you see a microphone in the bottom left-hand corner. The metalworking specialists and the kits that they have, their MillMax kits, come complete with their own microphone, and it's not a microphone that size, it's a much smaller microphone. But if they're on your facility floor and you're in a chatter situation and you're a MillMax customer of MSC's, they're able to listen to the chatter and enter in a couple bits of information into their laptop and actually tell you how to eliminate that chatter, finding the stable operating parameters without even tapping the tool. And to take that a step further, which seems almost like Jetsons-esque, aging myself a little bit with saying that, but it seems like it's way out there. We can actually, in a contactless environment that many of our customers operate in today, is if you are in a chatter situation, we can talk to you about how you can record that chatter using a mobile device. Send us a few bits of information about your operation, what material you're machining, what tool you're using, the diameter, and a couple other things. And then send us that sound file. We'll be able to take that, enter that into our laptops and run a diagnostic to understand completely contactless how to help you eliminate that chatter and therefore get better workpiece finishes, longer tool life, and longer machine life.
Without knowing the tool's frequency, the common response to chatter is to slow down the spindle speed, vastly underutilizing the capabilities of your machine and tooling. As we said earlier, every different tool, tool holder, machine combination vibrates at its own unique frequency. The challenge is that there are billions of potential combinations. MSC MillMax measures the frequency of each tool and instantly generates a dashboard that calculates the precise stable speed, feed rate, width, and depth of cut for maximum performance. It also determines the best speeds for surface finish and accuracy. You will always know where to run. This patented and proven technology is in use at the world's largest manufacturers. It is available exclusively from MSC's trained and equipped team of metalworking specialists. Contact your MSC representative for more information.
All right. So that video, folks, is available on MSC's website. There's a landing page for MillMax that's out there. Frederick, by the way, can you confirm that now you see my PowerPoint screen or slide?
Yes, we can see it loud. We can see it.
All right, perfectly. Good. Okay. With that being the case, I'm gonna show you a dashboard you should see, and this is our deliverable to you. So subsequent to tapping what we call an impact test or a tap test, but tapping that end mill strategically, identifying the response of that system together. It's connected to the laptop. This is what displays on the metalworking specialist screen, and as you can see and as you can figure, anywhere in green is a safe operating area. It's stable. Now, this machine had 14,000 RPMs. This dashboard is custom to that machine with that tool and that tool holder, giving you, complete certainty on how this system can operate. Green is stable. Yellow is you're going to start having some chatter. Red is chatter to the extent that you're probably going to break an end mill. And if you think about the processes that have been used in the past, like we used to use at MSC for testing milling cutters, the manufacturing community offers up a range of surface footage and what's called feed per tooth or feed rates that you calculate. And most people I'd say probably well over 90% of technical folks out there, MSC's folks included, would go to the middle and then listen and check out the load meter on the machine and any number of different things to determine, okay, what's that operating speed sound, or what does that operation sound like? And maybe that first shot using this educated guess and trial and error you hear a little bit of chatter. You might back it down a little bit. Maybe if it's aluminum, you say, you know what, turn it up a little bit, and you find this small, stable area. But it doesn't sound so good, so you move back a little bit. And what we find 90% of the time is our customers are operating here. Well, there's a couple other stable areas that are way out here and way up here. And if you can see that, you can actually make a determination moving this slider around of a depth of cut and width of cut. You can override if you want to and put your depth of cut in here or width of cut that you want to achieve, but you're able to maneuver this around it. If you put yourself in a position of, and maybe you are an estimator at your company or a programmer, that you can make the best determination for a cutting strategy just simply using this without all of the trial and error and wasted time on a piece of equipment. So we showcase for you here the metal removal rate. So, you might move this around in a roughing, situation and say, what is the best metal removal rate that I can identify? Select that, and you can see here that it, in this case, is at almost 6 cubic inches a minute. And like I told you, most customers are operating down here. It's almost 2.5, maybe 3 times the metal removal rate. That has a direct influence on your productivity, but it has a huge influence on your profitability, your ability to get more throughput, create more parts, and better earnings associated with it. So you may say that you want to do a tricoidal milling pass. You might want to consider almost like a high feed mill type thing. You might wonder, can you bury this cutter? Yeah, you can bury it, but you're going to be way down here. You can make those decisions here. Better quoting, less scrap the first time you're going to make a part. You know what you're doing going in. You also notice some other things down here I'll highlight for you. Not always is it the speed. Speed isn't always the thing that you're looking for. You may be looking for surface finish. So you're able to, and we'll train you and your folks on the ideal position to find the best surface finish. And maybe that helps you limit or eliminate, in some cases, other operations that become unnecessary because you now know how to potentially achieve the finish you're looking for right on the machine rather than, a post-machining operation. So I'm going to stop there for a second. I'm just going to check with Scott Stickney to see, Scott, are there any questions in the chat at this point?
Hey, Jamie, we do have a couple of good questions here.
Okay, great.
One regarding the microphone. Just a clarifying question. Did you say that by using only a microphone, even without characterizing the specific tools that are in cut or the machine, MillMax will be able to determine better cutting parameters to reduce chatter?
Close, but not quite. So we would need to know what is the tool, what is the diameter of the tool, how many flutes, how far is it sticking out, what material, and a couple other bits of information. Listen to that file, plug that into our laptops, and be able to listen. And let's say you're operating at 11,400 RPMs and it's chattering. And our system, with the appropriate information that's necessary, might say, hey, at 11,195, that'll go away. And that's the way that would work, Scott. So yeah, we definitely need information about the tool and the dimensions and whatnot in the material. But we would provide that to our customers so they know what to give us if they want us to do this in a contactless manner. It's a great question.
Okay. One more good question here. There's many other variables in milling that are not taken into consideration, like work holding, coolant, coatings. How do you incorporate that into this technology?
Yeah. So if we think about coatings, in most cases will allow for a greater, we'll say, resistance to heat, or it allows for more heat, which allow you to cut faster or improve tool life in a lot of cases. That doesn't really have anything to do with machining dynamics. That would be more about tool life that you would get. Great question. You'll see at the end, I have some frequently asked questions. So whomever asked the question, it's a really good one, is the work holding situation. And what we find, well less than 10% of the time is if there is chatter, again, which isn't all that frequent, but if there is chatter, that it's not because of substandard work holding. Essentially what happens if you introduced an unstable assembly or an unstable cut to that workpiece, it's going to impart instability on the workpiece, and it might look or seem like it's the workpiece. Certainly, there are work holding situations or fixturing situations where it could be better than what it is, but we have advanced ways with which, if we keep finding stable areas, and we were in a big, heavy green stable area, say on that dashboard, and we're still getting chatter, then it may very well be the workpiece, and we can actually tap that workpiece and kind of understand, is there a lot of flex in there? It's somewhat of an advanced application, but it can be done. But you'd be surprised how what few percentage of the time that work holding is the culprit. Again, that's a fantastic question.
Great.
Okay, any other ones?
One more that, is tool life taken into account? A new end mill cuts differently than a mid-life or one that's towards the end of their life?
Yeah, so of course, the longer a tool is in use, the less the tool life is going to be. So, you would still use the stable ranges that operate there, but just like anything, with MillMax, and actually it's a great segue. And I just added the slide, so it's certainly not a setup. Nobody's ever seen this slide before, but you have the ability to make a decision because of the dashboard, that we showed a moment ago, to determine, do you want or do you need the fastest speed possible? And you would go to that largest or that furthest green stable area on that speedometer. And at that faster speed, your tool life is not going to be as good in most cases, not every case, most cases, because of the heat that's created. But if you're making that much more throughput, you're getting products off the machine, you're going to have all the information in your hands that says, I still want to go faster, and that's fine. Or you can go with moderate speed, and you can achieve longer tool life. Think about businesses maybe like yours that are considering lights out operations. Well, maybe you want to see an end mill that's safe to operate throughout the evening, and instead of 200 inches a minute, 175 inches a minute is going to give you much longer tool life, and therefore you don't have to change it in the middle of the evening. You might elect for this middle, and sometimes it's all about the surface finish. But, as far as tool life is concerned, you're able to determine based on the dashboard and the information that's in your hand exactly how you want to operate. Scott, good? Any other questions before I continue?
Not at this moment. I'll answer some of these in the Q&A. Okay,
great. And again, great segue, whoever asked that question. So let's talk about some of the success metrics that we're seeing so far. As I mentioned earlier, we're finding that when we successfully tap a tool and we recommend, because we're learning new, what tools might work better in different materials and what holders work better and whatnot, we're seeing about a 90% success rate. And success rate means your operation is improved. And maybe, again, that's speed, maybe it's surface finish, maybe it's tool life. It's whatever it is that you expect, and we'll document that. I'll show you the documentation of it. But 90% of the time when we come in, we use this notion of machining dynamics and the MillMax kit to help us find that, where it's uncovering productivity metrics and possibilities that most humans just simply would not expect. If we think back to that dashboard, and you start to, you say, hey, we need to get the production out the door. Your customer is looking for you to shorten the lead time, and you try to speed things up, and you run into that yellow or red area, and you start shattering or breaking tools. Nobody's going to keep going and going and going until you find a stable area. And it just doesn't. Human nature is not that way. This will be able to tell you that. So the success rate that we're seeing, if you become a MillMax customer, is about 90% of the time we're showing an improvement. Those improvements are coming through with some of these metrics. And these are recently updated. These are higher than what we've socialized to date. When we launched this program back in October, We had done about 18 months worth of testing, and we became comfortable with what we'd share in the public. And we're seeing actually now that our metalworking specialists are out there nationwide, 125 of these guys that report into Scott, who's helping us here with Q&A, they all have this kit, and we're documenting our performance metrics and how we're improving customers. And on average, we're leaving, and maybe not the most important metric out there, folks, but it's an important one in some regards about machine utilization. We're seeing a 100% or 101% improvement in machine speed, or RPMs. Again, RPMs at the end of the day don't necessarily always create better profits or better throughput, but sometimes customers will buy a 20,000 RPM spindle or 25,000 RPM spindle, and we'll find that they're at, if they have a 25,000 RPM spindle, maybe they're operating at 17,000. Well, after a MillMax test, we're seeing that we're improving their RPM utilization. If we show up and you're at $5,000, we're leaving here at $10,000 on average. Again, and that's inclusive of all types of machines, old ones, new ones, BT30, Cat 50, horizontal, vertical, cast iron, titanium, stainless steel, all of those in the mix. The average improvement in machine RPM utilization goes up about 100% or double from what it is today when we show up. The second is a little bit above that is feed rate improvement. So once again, feed rate it tells more than RPMs, but it doesn't tell the whole story. But on average, we're leaving and we're seeing 107% increase in feed rates. So if you're at 100 inches a minute and 4140, for instance, steel, when we leave, you're over 200 inches a minute. And there is a correlation, some correlation to how that can help your profitability. But when we're talking roughing, maybe semi-finishing and getting rid of material removal rate for our customers typically is the be-all, end-all metric. That's the one that really tells you how you're performing. On average, we're seeing a 200% improvement, which is 3 times the current state of our customers when we leave after a few minutes of MillMax testing and then proving out that the tool holder and machine can take that kind of improvement. And so that's the average that we're seeing. That has a direct influence, and this is where, when we get back to those original metrics of those primary concerns of American manufacturers, is I want to be able to grow my business and I want to be more profitable and do so in the face of the skills gap. On average, we're up to 80 hours of capacity gains that we're giving back to customers. So we're showing you a speed with which to operate that's so much faster that if you ran that tool for the rest of the year, that particular milling operation picks up 80 hours of machine time. Now, think across a few different high-use end mills or face mills or shell mills at your facility, and those hours continue to add up. And so what do you do with those hours, You're certainly more profitable because you're knocking stuff out in a shorter amount of time. You're making your customer happy because you're getting product out the door to them. But now you have this time on your hands, and you can add a different customer and diversify your business. You can add more work from an existing customer that may want to rely on you some more. Or maybe you use some of that time to train an unskilled machinist, right? And you set up some kind of a training curriculum that maybe MSC can even help you with in that regard and upskill, your workforce there. But the choice is yours at that point of what you want to do with that time. Our average cycle time reduction, again, we're in the hundreds of tests, guys and ladies at this point, of more than 40% reduction in cycle time, again, on average. So what I would tell you is that if we do a demonstration or you become a MillMax customer of MSC's, you may see your first shot 10% cycle time reduction. But another tool that we might do might give you, a 70% reduction. But these are our averages, and I'm totally comfortable sharing those with you because it's across a long period of time and a lot of different tools and machines. Scott, I'll check in with you real quick. Anything else question-wise?
Yeah, we did get a couple more questions.
Okay.
Got some engineers on the call. I love it. Very technical questions. So
Me too. I love it too. I hope I can answer them.
Yeah, I know.
Yeah.
So can you set an RPM and work backwards from there to find the optimal feed, depth of cut, length of cut to avoid chatter and achieve the max MRR with this software?
Yeah. So you would be able to. You can override that to go to a rate with which you want. And let's say that's 5,000 RPMs. It's going to point you there. you'll be able to move this depth of cut and width of cut slider around, as well as the surface finish estimator to hopefully tell you the ideal way that you might be able to run. So the answer is yes.
Okay, perfect. One last question. How do things change if I'm doing plunge milling operation?
Again, you're going to have all the information available to you because it's going to tell you how that system wants to operate in conjunction with one another. It's actually the analogy that I use in many cases, whether it's with our internal folks or with customers is, on the other side of this wall, I've shared with people so many times, our laundry room in our home is across that wall. And sometimes the spin cycle of that washing machine, maybe the load isn't out of balance, but man, it starts to rattle and it feels like that thing's going to come through the wall. Well, that particular system at that RPM is unstable, but then you get up and you think you might have to do something about moving the clothes around, and then suddenly it's okay. And maybe you experience that in your car at a certain RPM or a certain speed that you're traveling, something's making a noise, but then it goes away at some speed. MillMax is identifying you where that stable speed is. And so you're able to maneuver your depth of cut and your width of cut and what that tool is capable of. And then plunge mill is no different really than would be any other kind of cutter. So you have all the information at your disposal to make that decision, Scott.
Thanks, Jamie. Appreciate it.
Welcome. Okay. So, folks, what you see on the screen now, we've got about 20 minutes left. I think we're making good time here. What you see on the screen right now is just one example of our what we call AppOp, short for Application Optimization. This is what you can expect in addition to getting a version of that dashboard, an HTML5 dashboard that is interactive, as you saw, and we just talked about it a couple times. That goes to you, but then we also will document for you what the improvements mean to your business. And here's an example of a modest savings that was done, a few weeks ago, a $13,000 profit improvement for a customer, again, on one milling operation. And essentially, in this particular case, you're going to see that in the inches per minute or the feed rate was at 12 when we left, it was at 70. So almost 6 times faster in terms of inches per minute. End mill usage is actually going to go down. So tool life was better. Annual end mill cost in this particular case, allowing for more throughput, the customer has that decision that they could buy more end mills, or if they hit what they need to in terms of their output to customers, can move that speed down and get more tool life. But in this particular case, the customer would elect to take on more work, and it ended up being a profit improvement for them of $13,000. So we give you all of this information, allow you to make what is the best decision. And for this particular customer, by virtue of these adjustments that were made, they have $13,953 more dollars in their pocket just from one test that took us 15 minutes to identify, that level of improvement. Some things that we don't document normally, but maybe considerations of ancillary benefits of MillMax. First is the cost avoidance. So the pandemic has been difficult for a lot of businesses, maybe some of yours, hopefully not, but it may have been. And the availability or accessibility of capital expense and investment in new equipment may not be in the cards. But with MSC MillMax, maybe you can get so much more throughput that you offset the need to buy another piece of equipment to grow your business or to hit your customer demands, of what they are expecting from you. Equipment wear and tear, running at more stable speeds. Your tools and your machine are going to last longer. Post-operation elimination. If you use that surface finish estimator, you may find that you can achieve the finish necessary on the equipment. Well, if that's the case, maybe there was an operation after the fact that, offhand operation and some abrasives or some buffing or something else was happening to achieve that particular finish. Maybe you can eliminate that particular part of the operation. And if you eliminate that part of the operation, you also eliminate all the products necessary to achieve those finishes, because now you're doing it right on the machine. Cutting tool expense in many cases goes down. I would say, I don't have a metric, and I'm just throwing this one out there. The 75% of the time, your expense in cutting tools goes down. that prior cost savings I just showed you, the cutting tool expense went up, but the overall profit for the customer was significantly improved because of the throughput they experienced. But that you have that choice. Do I want to spend less on cutting tools and I would run at this parameter? And maybe I have to spend a little bit more, but I get so much more throughput and speed that it's more profitable. The decision is yours. All right. Overall optimization, a reminder that it takes less than 15 minutes to achieve, the recognition of what's possible with that particular assembly. So lots of really cool things that happen as a result of employing or administering MillMax. So here are some recent, these are probably, but by and large, within the last 3 months. I would say I've highlighted the colors in a fashion of ISO material group listings. So, of course, blue is steel, yellow is stainless steel, red is cast iron, brown is super alloys, and green is non-ferrous in this particular case. And so you may identify that you machine in some of these particular areas. Recognize that what you see on the screen right now took less than 15 minutes to identify the operating parameters that ultimately our customers were able to benefit from. So the top one, 136 improvement in material removal rate for a medical customer that was machining titanium. I love the one below it that's in red and compacted graphite iron, where, automotive customers, folks that are making things like this, there's a lot of exhaustive testing that happens, and sometimes turnkeys and so on are built and made for this kind of work. And a lot of times, our customers don't believe that there's a possibility of doing better than what they do, yet our batting average of 900 or 90% of the time improving kind of holds true. But in less than 15 minutes, we were able to show a customer that makes engine blocks a 64% improvement in their process. The bottom left is an A105 steel energy or oil and gas job with $43,000 profit improvement. Took a cycle time from 2 minutes and 11 seconds for the milling part of the application down to 34 seconds. This one up top, some pretty significant chattering and post-operation work. In this case, the customer just wanted to get a more stable cut and found that they're getting 237 parts after using MillMax because of identifying stabilized speeds versus they were getting only 25 parts. So their end mill expense went from $5,700 down to $700 annually. So $5,000 of savings of purchasing end mills was an improvement for them. You can see the other ones, just significant improvements across the board. These capacity gains continue to be the fodder for you all to potentially add more work, add new customers, and so on and so forth. Maybe take advantage of the reshoring opportunities that exist out there today. Okay, so let's talk about how to get MSC MillMax. Try to check the time. We got 14 minutes. We're in good shape. So how to get MSC MillMax. It's interesting. So we collaborated with customers, customers just like you. And what I was going to say is maybe some of you, for that particular matter, about what would be the way that would make this appetizing, especially considering the pandemic and what's happening out there. So the first thing was first is, we kicked around, it's expensive technology. The metalworking specialists are an expensive resource. Maybe, we should just charge a service fee. So almost like a HVAC repair person might come to your house and, take a look at your air conditioning unit. And it costs $100 in their case to show up, just to show up. And then they tell you all the things that need to be done with it. And ultimately your HVAC charge might be, $700 or $500. Well, same thing could happen here. Okay, so it's going to cost for a metalworking specialist to get there. And then we're going to diagnose what's needed. And then we, invoice you for $1,000 or $1,500 or $2,500, who knows what. But in order to make it worthwhile for both the customers and MSC, it just wasn't working out. And you guys don't want to spend money on service fees if you don't have to. That's additional spend. Even if we were to document savings, that's a decision that you have to make. And it didn't seem to be a right fit. So we tried, the next one we collaborated with customers and thought about was maybe as a percentage of the savings that you agreed to. All right, so, hey, 10% of the cost savings. So if we document $10,000 of savings, we'll invoice you for $1,000. You keep the other $9,000, you should be happy, we're happy, we'll move on. Well, it's not out of the realm of possibility, particularly when we're able to get on shop floors more often than COVID's allowing us today. we'll have, I guarantee you, at least weekly, a $200,000 cost savings in America somewhere. And maybe that's at your facility. You know, are you going to cut us a check for $20,000 for 15 minutes of time? And probably not. It starts to get, you know, it's not cost prohibitive. That's a big check to write. So then we actually went right under our nose, and traditional business and business ethics would tell you, why not just redirect spend? We would ask for spend that you maybe spend with somebody else. We want to earn your end mill business. We want to earn your holder business. We want to earn your cutting tool business, your fluids business, your hand tools or power tools. We'll look for incremental sales that you already spend with somebody else. So net doesn't really cost you anything. You're just moving sales to somebody that's bringing, in this case, MSC, by virtue of MillMax, that's bringing extraordinary value to you. So maybe, let's just say our price was within a couple percent above or below what you're paying. So you move business to us, you're going to get consultations associated with MillMax that we guarantee they don't even count as a consultation unless we save you money, and we'll document it. So you're definitely going to be in the black when you work with MSC on MillMax, and it doesn't cost you anything different out of pocket than you used to spend before. So our salespeople will be in touch with you. Your key account sales consultant, maybe one of our telesales reps that works with you, will be in touch, and after this call, and they'll explain to you how all of those details work. But what we found from customers, I actually have presented to hundreds and hundreds of businesses at this point, and haven't had one person come back and say they think this is unfair. They're like, that actually makes a ton of sense. That's good old business. You do a better job or you bring value, then you earn the business. That's it. All right. So common questions about MillMax. We hit a couple of these along the way. And Scott, before I go here, do you have any that are on the list before I go through these ones?
Sorry, Jamie, I was just looking at some of the questions and answering some in the chat here, but I did get a good question on some of the demos were in solid tools. Is this good for indexable as well? And that may be on this list here. I don't know, but it did come through.
Yeah, it's the third question on this list.
Okay, good.
Again, this group is hitting it out of the park with really good questions. And yeah, so solid mills as well as indexable. There is a size range for the kits that our specialists carry with them. Ideally, the size range that we can operate within with the kits that we have is 3/8 of an inch up to 6 inches in diameter or thereabouts. That's more than 80% of the market as we see it. So likely, MillMax is a good fit for you unless you're, using a 24-inch diameter face mill or something like that, from time to time. Obviously, we don't see a bunch of those, and that would fall outside. But sometimes we do have customers that are using a lot of smaller tools. And we have invested in an additional kit right now, and we will invest in more if we need to, that allows us to go down as far as 3/16 of an inch up to 3/8. But for those very small sizes that may be under that, we would use that VP harmonizer or that microphone tool to identify if there's chatter, and if so, how to improve it. Because you can't stick an accelerometer and tap a tool that's that small under that stuff. It gets to be too little. So really good question. But yes, MillMax works just as well on solid as indexable tools. Any other questions, Scott, before I go through this list?
Just one last one. Question about regrinds, how it impacts this. Do you test at the different regrind diameters?
Yes. Yeah, you can do that, but actually a really cool strategy that you can, it depends the regularity or how much you want to use regrinds. And the answer is this. So let's say that you want to incorporate regrinds as much as you can. So what we would do is we would tap a new one and identify on the dashboard what is a great stable area to operate that brand new tool. But then we would do the same thing with a regrind and see that dashboard and find an area where both the new and the regrind can operate. And what we're finding is we might sacrifice a little bit on the new one, but we might gain a lot on the regrind, and you don't have to reprogram. You don't have to reprogram for speeds and feeds or anything like that with the regrind. So you find a stable area that works for both a new and a regrind, and you're off to the races. So that would be one strategy, but there's a number of different ways that you can attack that. But this definitely can contribute to success using regrind, Scott.
Thanks, Jamie.
All right. So, the last slide we have here, and if there's any other questions, feel free. Does MillMax work on things other than milling products? No, it's dedicated to milling from the standpoint of, milling tools have multiple flutes and multiple cutting edges, and some are in the cut and some are not. And by virtue of that, as you saw in the video, you have, deflection occurs. Deflection, will create chatter, and chatter kills end mills. Turning is, for instance, a constantly chipping application, just like drilling is. All flutes and all edges are always in the cut. So milling's unique in that perspective, and that's why MillMax is a little bit unique. I told you earlier, we can tap a workpiece to identify if there's some vibration in it. In some advanced applications, we could tap other things, maybe like a long boring bar if we had to see how much flex and how much vibration is going on there. But I would say, focus mostly on milling. Does MillMax work on live tooling and in the lathe? Absolutely it does. We can look to optimize that stuff, but what we tell our customers is that expect modest improvements. It might be the optimal, but it might not be significantly better than what you're doing today. And the reason is because you typically have some horsepower limitations there, maybe some RPM limitations or feed rate possibilities that exist in those spindles or in those types of pieces of equipment. We can optimize them, but just be prepared that the optimization might not be at the extent of some of those metrics I shared with you a little bit ago. We did the next question. We did the work holding question. Have any tools or tool holders emerged as better than others? Yeah, we're learning some really cool things that we're excited to take. We have to do some unlearning because some things that you wouldn't think are the case certainly become the case, to the extent with which if you want us to do a demonstration, which will be the last thing I share with you, and this is how we would introduce it to you on your facility floor, we're going to recommend a better end mill that we believe, based on all the things that we're seeing and that we're learning out there, and in some cases a better holder. What I can tell you is we're finding in some cases, in a lot of cases, the holder might have more of an influence on productivity and profitability than the end mill itself, frankly. And so, we've got to learn to introduce those to you, but we're seeing that certain types of tools are emerging as more successful than others. You have to tap a tool every time it's changed. The answer is no. Unless you crash a spindle or something devastating happens to that machine or that holder for that matter, you might have to have us retap it. But let's just say that machine has been operating just fine. You take out, the end mill that you're using or the face mill, and you're going to replace it with the same model, make and model or SKU as you had in there before. It's just a new one. As long as it's sticking out of the spindle the same length and it's cutting that material, it's going to be fine. You don't have to tap it. Is it better suited, MillMax, for production shops rather than job shops? What I would tell you is obviously for production shops, if you can rip a couple seconds out of a cycle time, then, that's a really great, success. For job shops, I would argue it's just as good. You think about the fact that you can understand the operating parameters in mere minutes. You can eliminate scrapping parts, eliminate test cuts, and all this educated guess on, hey, I haven't machined titanium in months or years. MillMax is going to be able to tell you, exactly how to get started. So maybe that part's up on the machine and you're making chips an entire day sooner than you would before. And if you take that across the course of a year, you're able to get out that many more jobs. It's a really good thing. So, I would argue it's great for both. So next steps, and we'll open up for any final questions. We're right on time. If you're interested, and I anticipate that many of you will be, upon having this webinar, we have a lot of customers that are very intrigued by the technology and a lot of, hey, I'll believe it when I see it kind of stuff. And that's exactly what I would want and do if I were you. So our folks will reach out to you shortly after this call, and we would do a free demonstration or a no-charge demonstration at your facility. If I'm you, I would pick a really regular occurring operation. Some folks want to say, give us the toughest application out there, and you give us a 3/8 tool that's sticking out 12 inches and it's machining titanium at the very bottom of with a funky radius or something. That's fine. I mean, we can look to optimize it, but fact of the matter is it's not a miracle worker. It's just going to tell you what it's capable of, and it might not be capable of much more than what you're already doing. But it's that 1/2 inch end mill, it's that 3-inch face mill that you use all the time. where we're going to find extraordinary amounts of success because there's operational improvements that you would otherwise not expect that you could get. So they'll outline what those next steps are. And then once you do the demonstration, we give you the dashboard, you see how it works. The ball is in your court at that point to say, yeah, you know what, I can see us using this and being involved with the MillMax service from here on out. So I'm going to open it up for questions. Scott, if there are any other final ones, we have 2 minutes and we'll knock out as many as we can.
Yeah, Jamie, we did have a few more here. Had a question about the software and hardware. Is it available for sale for a company or a customer to own and have all the time?
It's expensive, and so at this point, we've decided not to try to sell it. If we can bring it to you, essentially at no charge in return for incremental sales, that puts you in the best position, we think, and what customers have thought. So we haven't decided to sell it at this point. Again, it's a super expensive thing, and just rather employ it as a service at this point. Go ahead, Scott.
Got it.
Yep.
Can you tap from 10-inch to 24-inch diameter? Larger tools?
There are, from my understanding, we have not done that yet, but my understanding there are larger hammers that do not have the plastic tip on them. They would actually have more of a steel tip, because what you have to do is that you have to excite that cutter or that large mass of a cutter when you're getting to those sizes. So the possibility absolutely exists. It would require a different size hammer that we've not invested in yet. But if the opportunity was significant enough, I don't have a problem with us considering to do just that.
Gotcha.
Yep.
Last question, I think. Do optimum RPM ranges change over time? Can you use MillMax to tap a spindle and determine the spindle health?
Yeah, well, yeah. So, absolutely. So if you know that you're operating, and the wider the green area, obviously the better, because you have a little bit of play on either side. But if you're in a big, heavy green area that's saying it's stable, and suddenly you're getting chatter or breaking end mills, something changed. And so because of that, MillMax can essentially almost be like a diagnostic tool, where it can say, maybe it's the workpiece, maybe it's the spindle. Did this thing crash? Did something like that happen? A lot of times we can pinpoint and help you pinpoint what that might be. Good question. Any more, Scott?
No, I think that's it. I'll try to answer
a
couple more.
Listen. Yeah, that's fine. So listen, we appreciate the time that you spent. Hopefully you found this information relevant and compelling. Our sales folks will be in touch with you shortly. We appreciate all the business that you give to us already today, and look forward to growing an even more prosperous relationship on either side using MSC MillMax. I would say keep your eye on us in the coming months and years with other innovations that we have that we'll be delivering to the marketplace. We expect to keep challenging ourselves to do better for you. So thank you very much, and I hope everybody has a great and safe weekend. Bye now. Frederick, thanks for your help today. Scott,
thank you
as well. Thanks.
Thank you again for joining us today. This concludes today's web conference. You may now disconnect. All presenters, please hold.